Stack versus heap. Grasping the difference between these two types of memory storage can make the difference between your program crashing and... Alright, well, let's get into it. What are the differences you actually need to know if you're a programmer or if you're just interested in coding how memory works? This might be interesting. What is a stack? A stack is a special area of a computer's memory which stores temporary variables created by a function. In stack, variables are declared, stored, and initialized during runtime. It is a temporary storage memory. When a computing task is complete, the memory of the variable will be automatically erased. Stack section mostly contains methods, local variables, and reference variables. A heap is memory storage used by programming languages to store global variables. By default, all global variables are stored in heap memory. It supports dynamic memory allocation. The heap is not managed automatically for you, nor is it tightly managed by the CPU. It is more like a free-floating region of memory. So keep those in mind. Global variables, free-floating region, not managed. So far, you can probably already figure out that this spells fragmentation, which is the drawback. All right, so here we have a nice little outline of the key differences. Key difference: stack is a linear data structure. Okay, so in this way, you can think of a stack as a literal stack, like a stack of papers, stack of cards, a stack of whatever. It's a literal stack. So when you want to get to stuff in the stack, you can't just grab something out of the middle because it will no longer be linear if you delete something out of the middle. It's gonna smash or stack smash. So the memory is gonna move basically if you pull something out of the middle. It's a little risky because of that. As you might know already, pointers are just a reference to a piece of memory. So if you're referencing something in stack and something else moves and shifts all the others and all the memory addresses change, you run into weird problems. All right, I'm getting ahead of this. Let's keep reading. Whereas a heap is a hierarchical data structure. Why is that word so hard to say? Stack memory will never become fragmented because it's linear, right? Whereas heap memory can become fragmented as blocks of memory are allocated and then freed. So as things become allocated and freed, it doesn't just magically shift things around to make them efficient. Stack accesses local variables, while heap allows you to access variables globally. Okay, we already kind of talked about that. Stack, local, stuff at program runtime, inside functions usually, just temporary usually, and heap being things you declare that you always want to have access. This will be like just anything throughout the program that you always need to have access to, like your main things, like maybe your main fields for what your program does. All right, stack variables can't be resized, whereas heap variables can be resized. Now that's kind of important too. The whole reason they can't be resized is it would break the linear data structure. Everything else you would have to be moved. If you resize one thing, now everything else in the stack has to become shifted to a different piece of memory, and it's bad. It's real messy. So you just don't do it basically. But in theory, you could. It's just real messy. Whereas heap variables can be resized. That's because they're within these fragmented blocks or your free memory in general. So kind of makes sense that you can just copy around to a new space that has enough or just allocate it fragmented somewhere else, whatever you need. There's a lot of freedom there. Stack memory is allocated in a contiguous block, which should make sense, whereas heap is allocated in random order. Yep. So it's not necessarily random, but generally there's some algorithm it follows to use the next free space that makes sense. So it's more like heuristically curated. Doesn't require to deallocate variables. So yeah, these will usually get destroyed in destructors, whereas heap deallocation is needed. Stack allocation and deallocation are done by compiler instructions, whereas heap allocation and deallocation is done by the program. Okay, stack is linear, a heap is hierarchical. Stack has high access speed and heap is slower, and you can imagine this because in a heap you gotta skip over memory, you gotta go through fragmentations basically, whereas a stack you can just fly through the memory one at a time until you get to what you need. So it's always linear access speed as far as data complexity. Space management. space managed efficiently by the OS, so memory is never fragmented. Heap space is not used as efficiently. Memory can become fragmented, first allocated then freed. Okay, access, local variables only. Heap access allows access to variables globally. Limit space, the limit of a stack size is dependent on the OS. It does not have a specific limit on memory size. The allocation deallocation, stack is automatic by compiler instructions. Heap is manually done. Explicit deallocation needed for a heap. Okay. Stack is cheaper. Declaring globally on the heap is more expensive. So that's pretty important. Okay, the implementation. This is where it's going to get a little more critical for us as programmers. A stack can be implemented in 3 ways. Let's change gears a little bit. So in practice, stack and heap is a little more complicated because you have to take into account things like your compiler and the optimizations it's trying to do. Okay, so I tried to ask the question, does a vector use the stack or heap? Because initially, when I looked at it, I wasn't sure. I found an answer to that on Quora. We're going to read it here. Does standard vector use stack or heap memory? Why? And the top answer, and I'll just read it here. Each non-empty standard vector uses 2 separate contiguous memory regions. One has a fixed size and holds the 3 pointers, or equivalent, and the allocator. The other has a variable size and holds the object stored in the vector and optionally some extra uninitialized space. They can both be on the stack, heap, static, shared, mapped, or any other kind of memory available to the program. By default, if no allocator was provided and the operator new was not replaced, and heap allocation was not moved to stack by the optimizer, the variable length chunk is on the heap, as noted in other answers, and the fixed size chunk is wherever the vector object was created. I imagine this is all most people will be able to take on the subject, but there's a lot of info out there. If you find any awesome resources, feel free to either share them here or in Discord, where we do have a channel. Just put them in like the computer science discussion or something. All right, I'll see you guys later. Peace out.